So earlier we were looking at this pattern at identifying the charges of given elements on the periodic table. And we were skipping this big section in the middle here for the transition metals. Now, the transition metals themselves, they do form ions, but they don't fall into any given pattern here. So that's really unfortunate for us that we can't really identify right away what the transition metal ion charges are going to be. That being said, though, we don't really need to memorize all of these, and we don't need to even use a reference table or anything to look these up. What we can actually do is for these, um, instead of memorizing all of them, it's given to us in the formula name. All right, so for example, we have iron, Roman numeral 3 chloride. So this Roman numeral here is identifying the charge of the positive metal. So the positive charge of the metal. So over here we have iron, which is Fe, and then the 3 represents the +3 charge, and then chloride. So the entire formula, remember that chlorine forms a -1 charge. So if we have a +3 and a -1, we're going to need 3 of those -1s to balance out that +3. So the entire formula is written like this: Fe plus 3Cl gives us FeCl3. Right? This means that the iron atom has a charge of +3. So now let's take a look at practice problem number 6 really quick. All right, so practice problem number 6 is going to follow the same steps and rules that practice problems 3 through 5 had. Once again, if you'd like to tackle this on by yourself, go ahead and pause the video right now and work on these, and then you can check your answers later. Otherwise, we're just going to work on these one at a time. 6a wants us to find the name of the following ionic compounds: iron 3 chloride. We're actually not finding the name, we're actually finding the chemical formula here. So for iron, we don't even need the transition metal chart because it's given to us right in the name. So iron is the first element, it's Fe, and it's got a +3 charge. How do I know it has a +3 charge? It's because of this Roman numeral. Once again, it's got a +3 because of the Roman numeral 3. Iodine has a symbol of I, and I know based off of our chart here that it's got a charge of -1. Well, if I have a +3 charge here and a -1 charge here, I need more negatives in order to balance out this positive for it to equal to 0. So if I had 3 iodines and they each were -1, that would balance out the Fe with the +3 charge. So I can write down FeI3. That's the final formula for practice problem 6a. 6b, it says copper 2 bromide. Copper's symbol is Cu. Bromine's is going to be Br. And then for the charges, copper was a +2 charge. And then bromine, if I take a look at this chart right here, it's right under that same column that iodine was in. So bromine is a -1 charge. So +2 and -1 don't balance out to 0. So I need more negative Br for it to balance out to 0. +2 and then -1, -1. That goes to 0. So my final formula is CuBr2. All right, 6C, cobalt 3 oxide. Cobalt is going to be CO. It's got a +3 charge, and I know that right away. Oxide is going to be oxygen, and oxygen's right there, right underneath that -2. All right, and that little tip that I told you about before, the only way you can ever get +3 and -2 together is if you have them going to 6. So -6 here on this side, and then +6 over here. So CO +3. So the final formula is going to be CO2O3. All right, what about silver bromide? The symbol for silver is Ag. And it doesn't have a Roman numeral. So we can kind of assume at this point that the charge is going to be +1. If there are no Roman numerals, you can just put a +1. bromine is right here, and then right underneath the periodic table, it's going to be in that same column as iodine and bromine were before. We already dealt with bromine, so that's going to be a -1. +1 and -1 already balance out, so that's great. So we don't need to add any more of each, so we're going to put AgBr as our final formula. And then finally, titanium 3 bromide. Titanium, which is Ti, has a +3 charge, and then bromide, or bromine, is Br, and we just dealt with that a few times, so that's -1. +3, -1. You can kind of guess at this point how we need to balance this out, but the final formula is going to be TiBr3. Alright, so that's practice problem number 6. The last thing we're going to talk about in relation to ionic compounds is something called the polyatomic ion. Okay, so the prefix poly means many, and atomic refers to atoms. So it basically means an ion that is basically made up of many atoms. Okay, so that's basically what it means. Ions that are found together as a group of other atoms. So basically, when we see, for example, ammonium, we have NH4, and that entire group of atoms, there's 5 atoms, 4 hydrogens and 1 nitrogen. So these 5 atoms together, they will still have a charge of +1. A nitrate is made out of NO3, so we have N and 3 oxygens. When they group together, they're all going to have a -1 charge. All right, so polyatomic ions, when they bind to normal metals or non-metals, what they're going to do is behave as if they're one atom. All right, so let's talk about calcium nitrate. So calcium has a +2 charge like this. And nitrate, if we take a look at our reference table, is right here, NO3. This entire group, NO3, has a -1 charge. All right, so right off the bat, we know that calcium has a +2, NO3 -1. These two are not going to balance out to 0. The only way to balance them out is if we include more negative. So we need more of this nitrate group in order to balance out the calcium. So the way we write that is we have Ca for calcium, because we only need one of them, and we need 2 of these groups in order to balance that out. So we're going to put NO3 in parentheses because we're multiplying that entire group by 2 and putting a 2 on the outside. And once again, just to reiterate that the parentheses are needed since, in this case, 2 nitrate ions are needed for the 1 calcium ion. So polyatomic ions, they're not too tricky, but basically we just want to note that these groups of elements, these specific groups of elements, are going to have a charge. And there's only a few examples that we're going to talk about, just these 6. So, all right, so let's take a look at some practice problems for this. We're going to take a look at practice problems 7 through 8 to conclude this lesson. All right, practice problem number 7. What we're going to do is just name the following compounds using a couple of transition metals, but the big focus being here on polyatomic ions. So let's go ahead and start with 7A, where iron 2, so iron here has a +2 charge. So we have an Fe, and that's going to be a +2 charge. And then phosphate, so based off of our reference table, we know that PO4, this phosphate group, this entire thing has a -3 charge. So again, the only way to balance these out so that they get to 0 is if we have this go to 6 and this go to 6. So we'll need 3 of these in order to get to 6. So we're going to put Fe3, because 2 times 3 will give us +6. And then we'll need 2 of these entire things in order to get to -6. So I'm going to put this in parentheses, PO4, and then we'll need 2 of these in order to balance that out. 7B says chromium 3 hydroxide. So chromium is Cr, and it's got a +3. Oh, actually, let me stick to color coding here. Cr +3, and then hydroxide is going to be right here. It's going to be an OH minus. So this entire thing, OH minus, it's going to be a -1. All right, so we're going to need 3 of these in order to balance out that Cr +3. So in this case, we're going to put Cr, and we only need 1 of these because it's going to stay as is, and we need 3 of these. So again, parentheses, OH, and then we need 3 of them. All right, iron 3 nitrate for 7C. Iron has a +3 charge this time instead of a +2 charge. And then nitrate is going to be NO3. And this entire thing has a -1 charge. So to balance this out, we're going to need 3 of these in order to balance out this one Fe. So Fe stays by itself, and then nitrate, once again, parentheses, so NO3, and we have 3 of these. All right, and then finally magnesium carbonate. Magnesium on the periodic table, I don't have it out with me right now, but it's in the second column, so it's going to be a +2 charge. And then carbonate here is going to be right there. It's going to be CO3, and this entire thing has a -2 charge. Okay, so +2, -2, those already balance out, so we can just write out MgCO3. And that's it. So that's for practice problem number 7. All right, practice problem number 8 is just basically filling out this chart. We're either providing the formula or we're going to be naming the compound. Providing the formula is a little bit trickier because we have to actually find the charges and make sure that it's balanced out, but it's not too bad. So cesium chloride is going to be our first example, and what again you need to do is identify the elements. So cesium is CS, so I'm actually going to write it just here in the margin, CS, and CS has a +1 charge, and then chloride is going to be the negative, so that's going to be Cl, and chloride has a -1 charge. So those actually do balance out together, so that's actually really fortunate for us that we don't have to add any more of them. So it's just CsCl. For the second one, we have CaSe. So for naming them, we're kind of working backwards now. So naming them, remember that the metal actually doesn't change name. The first part doesn't change its name. So it's going to be calcium. And then the element Se, which is right here, that's selenium, right? But we're not going to call it calcium selenium. We actually need to change the ending, and if you recall from earlier, we're changing the ending to IDE. So it's calcium selenide. Okay. Part 3, barium sulfide. So barium, which is going to be Ba. So I'm just going to write that here in the margin, Ba. Has a +2 charge. You can identify it right there from our table. So +2. And then sulfide comes from sulfur. So here's sulfur. And it has a sulfide, which is a -2 charge. So barium sulfide, +2, -2. That actually equals out to 0 already, so we can put BAS, barium sulfide. Okay. Iron 2 sulfide, so iron we have Fe, and we don't need a periodic table or anything because it gives us the charge right there, so it's a +2. And then we just dealt with sulfide before, it was a S -2, so we can put in the formula FeS. All right, so for this next one, what we need to do is actually name this, but what we'll notice here is that the symbol Ni doesn't appear anywhere on this chart here. It actually does appear in the transition metals. That's the part that we actually skipped over right here. So when it does have a transition metal, we need to include the charge in the name. All right, so the way we would do that is by identifying what this charge is and how many we have. So O is for oxygen, and we only have one of them, right? So oxygen has a -2 charge, and we only have one, so we know that the negative side is going to be -2. Okay, so we could put just like a -2 there for reference, and that means this nickel has to be a +2 for it to balance out to 0. So I'm going to put down nickel as my metal. And because the charges balance out without having to add any more, we could put in Roman numerals that the charge is 2. And then the O stood for oxygen, but we're going to have to write it as oxide. And that's pretty much it for this problem right there. All you have to do is for the transition metals identify the charge of it. And we do that by looking at how many we have of each and how many, what the charges were for the initial ions. All right, so for lithium 2 oxide, that's basically this one. We know that lithium is right there, but do we need to write it down as a parentheses with a 2? Well, it basically depends if it's a transition metal or not. If we can find a lithium here on our periodic table, we do not need to do that. We only need to do this in the case of transition metals. In this case, lithium is an alkali metal. It's right there. And we don't need to include the charge there because it's given to us in this version. So we'll just call it lithium oxide. All right, so we're going back to finding the chemical formula. So we have copper to fluoride. Copper is going to be Cu, and it gives us a charge of +2. Fluoride is going to be F, and it has a charge of -1. So in order to get those balanced out, you need to have 2 of the fluorides. So CuF2. All right, so for the final ones, potassium phosphide. Potassium has a charge of +1, and phosphide has a charge of -3. So I'm just going to wrap this up pretty quickly. Potassium, +1, -3. This is one of the very few charges where you've seen a positive charge be less than the negative charge. This is, I think, one of the first times we've seen this in this set of notes. So what you need to do is have 3 of these +1s. So you need a +1, a +1, and a +1 in order to balance out the -3. All right, so potassium and phosphide, we only need 1 phosphide, so we're going to put that there. And then for potassium, that's the letter K, and you need 3 of those because we have 3 + 1 for the 1 -3. All right, the last one is going to cover a polyatomic ion, NH4, which is, if we take a look at our chart, ammonium, and we have 2 of those. Okay, so and then we have Se, which is selenium. So we have identified the first one, which is ammonium. But then I'm not going to write selenium because it's not called ammonium selenium. It's called ammonium selenide. So remember that we need to replace the endings so that the endings for the ionic compounds are "ide." All right, so that concludes Notes 1 for Unit 3.